All right. So, what is the root word of the word rational? Ration. Close. Right idea. The root word is ratio or rate. Okay, a rate is a ratio. So all of these expressions right here are all rational expressions. Every one of those is a rational expression. They can be really easy, like the fraction 3/4, or really ugly, like some of these that have ugly polynomials on the top and on the bottom. Okay? Rational expressions, okay, when we say the word rational, what we're really talking about is a fraction. Okay? And although fractions aren't our favorite, we do have to work with them. Okay? You should get it to the point where you don't mind working with fractions. Okay, because that's what most of this section is about. And you're going to see them in 1050, so you might as well get used to them now. Okay, so basically they're little fractions, they're little division problems. All right, and this is going to be easier if we keep a couple things in mind. So the first one is this. When we simplify a rational expression, okay, we cancel common factors. So we find common factors in the numerator and the denominator, and we cancel them. Now, we throw around the word cancel a lot. So when we say cancel, like we're going to cancel something here, what we mean when we say cancel in a division problem is we mean they cancel to be 1. Cancel to be 1. So I've got two canceling problems here, and I've got canceling in quotes because these are different types of canceling. Okay? Let's do this one right here. What cancels on this one? Okay, the 3 and the -3. Okay, but when they cancel, what do those cancel to? They cancel to be a 0, so that's why we don't have to write them anymore, and we just write 4x. When we do this problem right here, this is 3 times 5, and this is 4 times 5. And what we cancel is the 5. Now when I cancel those off, what am I canceling it to be? Yeah, it's not a 0 like it was on the other problem. Technically, there's a 1 left on the top and bottom, so that's 3 times 1, and that's 4 times 1. So when I simplify that, that's 3/4. Now, everybody here probably started doing this stuff in elementary school. You can simplify 15/20ths in your head. You don't think about it that way, but you should at least remind yourself that when we cancel using division, we're canceling off common factors, and we're canceling them to be a 1. Okay, so be careful about the way you throw around the word cancel. Okay, those cancel to be 1. Those cancel to be a 0. That's the difference between the two. Okay, so let's take a look at these next problems right here on example 2. I've got 2x minus 6 over 2x, and I want to simplify this. Now, can I do this? 2x with 2x. Nope, you can't. Okay? Just like the one up above. Everybody knows how to work with numbers. Those are pretty darn easy. But when we throw something like this in there, it's more complicated. You can cancel factors. We cancel common factors. You cannot cancel that 2x with that 2x because the one on the bottom, that's a factor of 2x. This is a term. So that's why I've got this right here. And please don't forget this. Okay, I even have to remember 1050, 1060. I remind calculus students, you can cancel factors, you cannot cancel terms, no matter how much it looks like you should be able to. So when we're doing this problem, the correct way to do this is to do it like this. We can simplify it, but we have to get factors first. So can I factor the numerator? Can I factor 2x minus 6? Yeah. Sure, we run through our list of factoring rules. What's the first rule? Take out greatest common factors. So I can take out a 2, I'm left with an x minus a 3. Now that x minus 3 has 2 terms in it. It's certainly not a difference of squares or difference of cubes. So that one's prime at this point. I can't break it down anymore. The numerator is factored completely, if you want to think of it that way. And the bottom, just to kind of belabor the point, I'm going to write that as 2 times x. So on the top, I have a 2 times x minus 3. And on the bottom, I have a 2 times x. Do I have any common factors? I have a 2. So I'm going to cancel off this 2 with that 2. They cancel to be a 1. So that means on the numerator, I've got this. I've got an x minus a 3 over 3. And my gosh, that looks like we ought to be able to cancel the x's. Can we? You can't. Why not? Wow, we got something go on there. They're married. Okay. Apparently some teacher before said you explained it like if these are together using a plus or a minus, they're married, so you can't break them apart. You got to keep them together. You can cancel it with another married couple, I assume. Very nice. Okay. That's the answer. Okay. All right. Well, let's see what married couples we can come up with here. Okay. You cannot cancel the x with the x squared, and you can't cancel the 2 with the 4. I'll let you say it because they're married right now. Let's see if we can come up with a different marriage here. Let's factor these. So this is a difference of squares that factors to x minus 2 and x plus 2. And the bottom is an x plus 2. Now, this is completely factored. If I had to drive home the point, I could put this in parentheses. What would have to go outside? What can I pull out of both of those? A 1. Okay? It's kind of a silly thing to write here. Yeah, I really don't like that marriage thing. That just seems strange to me. But do we have any common factors now? Okay, please don't do this. Everybody watch, please. Every year I'll see people, I'll look at their work and I'll see this. Is that the right way to do it? No. The right way to do it is to recognize, staying away from that marriage thing, I'm canceling that entire factor with that entire factor. So that means what's left on the top is an x minus a 2. Technically, what's left on the bottom? A 1. Do I have to write it in this case? I don't. We just want to write that as x minus 2. Now, if this problem had been flipped upside down and the 1 was left on the top, would I have to write it there? Yeah, because otherwise there's no bottom if I don't write the top, right? Okay. Any questions? Yeah.
So you can cancel out the factor in that, or the term in that, but not in other ones.
What do you mean? What term did I cancel?
Like with the previous problem, you had 2x, and you didn't cancel out the x, but in this one you got rid of the x.
Yeah, but that was because these two are together. This is one entire factor. That's one entire factor. Okay, it doesn't have anything to do with whether it's a variable or a variable squared or a 2 or a 3 or a 9. It has to do with this is one entire factor here, and that's one entire factor. They are the same factor, so same thing over same thing makes a 1. Okay, cancels to be 1. Clear on that one? Okay. That's the first thing you want to keep track of when you're dealing with rational expressions, is you can simplify them. You can do that through canceling. You cancel to be 1. You cancel common factors. You cannot cancel terms. Got that straight? Okay, let's take a look at the second thing. Since rational functions involve division, you've got to be careful about the domain. Remember, what number can't you divide by?
0.
You can't divide by 0. So we talked about 3 functions that have domain issues. One is division. You can't divide by 0. We talked about another one. Even roots, square roots, fourth roots, and so forth. You can't take the even root of a negative. And we mentioned another one that's going to come up later in the year. Does anybody remember what it is? Logarithms. Okay, we don't have any logarithms yet, so don't worry about that. Even roots and division. You better be careful with domains. So let's take a look at this one right here. This is the function. It happens to be a rational function, is what we call it. You can plug anything you want in except what will make the denominator 0. So if we're going to solve this, we could do this. We could say x minus 4 equals 0 and figure out what number that would be and then just cross it out. Or we can say, you know what? This better not equal 4. We can have a not equal in there to begin with. X had better not equal 4. Because look, if you plug a 4 in, what's the bottom?
0.
It's a 0. Okay? And that's not allowed. Okay, let's take a look at this one because this is kind of an interesting example. What number can't I plug in?
-3.
Okay, you can't plug in a -3. Now, does it matter that I can factor this, cancel off those common factors, and this behaves like 6x? It doesn't, because the original problem had an x minus 3 in the denominator. Okay, so it wouldn't be able to equal -3. Okay, are there any questions there? Okay, so those are domain things that come up with rational expressions. They come up because rationals involve division, and you can't divide by 0. Okay, good? All right, so you've got some problems like this. We're now ready to do problems like you're going to see on your assignment. It says for each rational function, find the function values indicated, provided the value exists. So, what does f of 0 mean?
It's like a 0 wherever.
Yeah, it means plug in a 0 wherever there's an x. So, I'd plug in a 0 here, plug in a 0 here, and plug in a 0 here. Well, that would be 0. That would be 0. So, what's the top?
-5.
-5. Plug in a 0 here. The bottom is -1. So, my answer is 5 for that one. Plug in a -1. I think -1 will work. Okay,
Oh, it will work.
because the bottom will be -2. This is going to be -1 squared. That's 1 times 2, so that's a 2. What's a minus -1? That's going to be a +1, and then -5. So let's see, I've got, well, that's a -2 on the top, right? And a -2 on the bottom. So f of -1 is 1. So let me write that again over here. F of 0 is 5, and f of -1 is 1. Okay? When we did function notation, I said, even though function notation looks kind of confusing, there is something really nice about it. What point is on the graph? 5's the y-coordinate. What's the x-coordinate? 0. 0, 5 is on the graph. What point does this say is on the graph? -1, 1. So we plugged in the x, we got out the y value. So there's our xy pair that we could graph. If I plug in a 3, so I'm going to quickly do this one. So if we plug in a 3, that's 3 squared, that's 9. 9 times 2 is 18. -3, -5. So that means the top is a positive 9, right? And the bottom? 3 minus 1?
It's 10, not 9.
Oh, is it 10? Oh, that's right, 10. Thanks. Top's a 10, bottom's a 2, right? So the answer here is 5. And then let's plug in f of 1. Zach? That one won't work, because when you try and plug it in, you get a number on the top, but what's the number on the bottom? You get a 0. So it doesn't really matter what's on the top. We're dividing by 0, so this, we could say it does not exist. F of 1 does not exist. There is no point when you go to 1 on the x-axis. Okay? Any questions? Yeah.
So is that graph, if we were going to graph that, that wouldn't be linear, would it? Because there's 2 y coordinates.
Let's see, does this factor? No, it doesn't factor. It wouldn't be linear. No. If it were linear, it would have a little hole in it at 1, which we'll talk about. Not today, thankfully, but eventually. Okay? All right, so then some easy problems. Simplify by removing a factor equal to 1. Now, the instructions on these are more confusing than actually doing the problem. All it's saying here is simplify, cross off common factors. So let's take a look at the numbers. I've got an 8 and a 40. 8 goes in here once, 8 goes in here 5 times. So I've got a 1 left on the top and a 5 left on the bottom. I've got 1 t on the bottom and 4 t's on the top. That means one of these is going to cancel. How many are left? 3. So on the top, I've got t cubed, and on the bottom, I've got a 5. That's it. Done. End of story. That's the problem. So let's take a look at the next one. I've got a 35 on the top and a 5 on the bottom. 5 goes in here once. 5 goes in here 7 times. I've got an n on the top and 2 of them on the bottom. That means one of them is going to cancel. So on the top, I've got a 7, and on the bottom, I've got an n. I'm done. What if I said that was a function? What's the domain for this function, or what's the domain for this expression? Everything except what? Everything except 0. Okay? Look at this one. What's the domain for this? All real numbers. Why does this not have an issue? Because the bottom is a 5. It's a constant. It's always 5. It's never going to be 0. Not going to have a problem with that. Okay, so let's take a look at the next one. It says, write each in simplified form. Be sure to list all restrictions in the domain. So if we were going to do this problem right here, look at this as simplification. So the first thing we're going to do is we're going to figure out what factors we have. So we have 5 and x plus 6. We have x and x plus 6. Stop right there. We factored everything. Now do the domain. What numbers are not allowed to be plugged into this particular function? What would make that one 0? 0. So x is not equal to 0. And what else? What would make that one equal to 0? Negative 6. Okay, now we can finish the problem. So the problem, or the function now is, can I simplify this? I can. I can cancel off that entire factor. Again, please cross it off the right way. Those two cancel to be a 1. So the simplified version of this is 5 over x. There's the simplified version. Here's the domain. You still can't plug these in. Okay, you can see you can't plug in a 0. You can't plug in a negative 6 either because you couldn't plug it into the original one. So you shouldn't be able to plug it into the simplified version. Yeah.
So say we were doing the same thing, but we did get earlier that the domain couldn't be 0. We got 5 over x, and should we put the 0 also in the domain if that ever happens?
Yeah, but okay, so here's Zach's question. What if I got just plowing along and I did this and then I looked at this and I said, oh, I need to figure out what the domain is. I can't plug in a 0. If you do it on the simplified version, you're probably going to get part of the domain restrictions, but not all of it, because we already canceled off one of the problems. We already canceled off the thing that told us we couldn't plug in a negative 6. So it's always a good idea to factor, figure out the domain, and then carry out the rest of the simplification. Okay? Do it in that order and you won't make mistakes. John?
So for the first, going back to the problems before, the domains, they can be equal to anything that's 0 over 0. 21, 22.
These guys right here?
Yeah, the domains has no restriction.
Okay, the domain has no restrictions on this. Are there any restrictions on this?
Well, 0.
Yeah.
The problem before.
N could not be equal to 0. Is that all right? And why aren't there any restrictions on this one? Why can you plug in anything you want?
Because there's nothing in the domain.
Okay, there's no variable in the denominator. Okay, the denominator is a 5. It's always a 5. There's nothing we can do to change that.
The problems before where you have to find the domain.
Which ones are you talking about?
I'm talking about like 35 over n, or 35 n over 5 n squared.
This one right here.
Yeah. That would have no restrictions because it'd be 0, 0. But
No, there's still a variable down here. There's still an n squared there. So what couldn't you plug in? If I plug a 0 in, it would make the denominator equal to 0. Does that make sense? Okay. But again, the best technique is factor, figure out what the domain is, throw in and out anything that won't work, and then simplify it. Okay? So let's stick with that again. On this problem right here, we're going to factor. So that's going to be a 3 and an x plus 10. See why you need to be good at factoring? We do this really quickly. Take out an x. You're left with an x plus 10. What do I do next? Domain. So the domain would be anything that is not equal to 0 because of this one, and negative 10 because of that one. And then the simplified version, 3 over x. Okay, that's what it would look like. Okay, now let me just say one other thing about the test. I saw people writing down answers that looked like this. Oops. There were 2 answers to a problem like 5 and negative 6, and they'd put them in parentheses. X is 5 and x is negative 6. Should you put those in parentheses? No, because then it looks like an ordered pair. It looks like an XY or something like that. If you want to put them in something, and you don't need to, put them in set brackets. Because what that's saying is one of the answers is 5, another answer is negative 6. Okay? Or if you really wanted to be clear, you could write this. Okay? But just writing 5 comma 6 without the parentheses, or if you're going to put something around them, put those little braces around them, and then you're in good shape. Okay? All right. Any questions? Okay, go ahead and flip the page over. Again, got to be good at working with fractions. So we're going to learn how to do operations with these. Most of today is multiply and divide. So if we looked at a numeric example of the type of stuff that we're going to be doing today, you had to add fractions or multiply fractions, which one's easier? Multiplying is, right? Because all you do is multiply straight across. So this would be 3 over 20, and that would be the answer. If I'm going to do this problem, I've got to get a common denominator, so I need to make this a 20 by multiplying the top and bottom by 5. Multiply the top and bottom by 4. So this is, well, let's see, that's 15 over 20 plus 4 over 20, so I get 19 over 20. That's a bit of a pain in the butt. So, oddly enough, even though generally adding and subtracting is easier, with fractions, it's actually better to learn multiplication and division first. Okay, any questions? Okay, I need your attention then. Watch, please. Okay, if I were doing this problem right here, 3 over 4 times 1 over 9. Okay, here's what I've run into lately. Okay, and if this is you, don't worry about it. Don't feel bad. I see this all the time. For some reason, in elementary school and in middle school, it seems like they don't emphasize this enough. They say, hey, just multiply straight across and get 3 up here and get 36 here and then simplify. Is that the easiest way to do this problem? No, because when you've got a multiplication problem, this is called cross-cancellation. Even though 3/4 doesn't simplify and 1/9 doesn't simplify, because it's multiplication, and the 3 and 1 are going to end up on the top anyway, and the 4 and 9 are going to end up on the bottom anyway, you don't have to just be restricted to canceling bottom to top like this one and this one. We could cross over and say, you know what? A 3 goes in here once, a 3 goes in here 3 times, and then I get 1 times 1 on the top, 4 times 3 on the bottom. That's the same as 336. It's like reducing before you even multiply. Wouldn't you rather work with smaller numbers and smaller expressions? Absolutely. Okay? And if you're in the habit of always multiplying across and then simplifying, life is going to get really difficult starting today. Okay? So cross-cancellation is your friend. It allows you to reduce the problem before you even do it. Okay? So let's take a look at this problem right here. I could multiply these across and get 30y cubed z to the 4th. And on the bottom I could get 35y to the 6th z. But it would be much better if I did this. Let's cancel. Let's look at the numbers. 5 with the 10. What's the 10 now? A 2. I'm going to cancel this z with one of these. How many z's do I have now? 3. I'm going to cancel these 3 y's with 3 of these. How many are left? 3. So let's take a look. Sometimes it can get a little bit confusing to keep things straight. I've got a 3 and a 2 on the top. I've got a 6. And I have a z to the 3rd. What do I have on the bottom? A 7 and y to the 3rd. Now take a good look here. Can I reduce anything? No. That's the beauty of cross-cancellation. Once you get the answer, if you've cross-canceled appropriately, simplified answer sitting right there. Okay, any questions? Okay, let's look at the next one. Let's think about what we're going to cross-cancel. I'm going to do the numbers first. 5 with the 20, that's going to be a 4. 6 with the 9, the 6 is going to be a 2, and the 9 is going to be a 3. Now, it might be helpful if we wrote down, that leaves me with an 8 on the top and a 3 on the bottom. Okay, so now I've got the numbers taken care of. Let's look at the variables. I've got a y here, 2 of them on the bottom, so 1's left. I've got 4 z's on the top and 7 on the bottom, so I'm going to cancel these 4 with 4 of those, so how many are left down here? There were 7, 4. So I cancel 4, I've got 3 left. So that's going to be z cubed on the bottom, y on the bottom. Anything else on the top? Nope, just the 8. So if you want to do the work like that and then clean it up, okay, that'd be fine. Yeah.
So it doesn't matter, like the variables, or it doesn't have to go in doesn't have to go to y.
Like in alphabetical order. Yeah. No, if you wanted to write it like this, you might find that answer in the back of the book or something like that. Either one's fine. Okay. I'm not sure if Math Excel likes them always in alphabetical or not. Okay? All right. Any questions? Okay, take a good look at the next one. Same idea. It looks much worse, but it's exactly the same idea. You do have to do a little bit of rewriting. So we're going to rewrite this as its factored form. Y minus 3, y plus 3. Y squared times. Take out a y. See all the factoring we're doing? Factor. Already factored. Factor. Take a look at this. Easy trinomial. Glad you did really well on the factoring for the most part. I need numbers that multiply to be -6 that combine to be -1, -3, and +2, right? Now let's take a good look and let's cross these off the correct way. I can cancel off that y plus 3, or y minus 3 with that y minus 3. Take a good look. Would it matter if I canceled this one off with that one? No, because there's still going to be a y minus 3 and a y plus 3 left. What else can I cancel off? Okay, I can cancel off this y with one of those. Anything else? Nope. So here's the answer. Y minus 3, y plus 3, y, and y plus 2. Now, for some reason, some people have an urge to multiply these together and multiply these together. Should you do that?
No.
You shouldn't, and here's why. Because anybody, including your teacher grading the test, can look at that and say, my gosh, they left it factored. I wonder if anything cancels. Nope, it's already in factored form, and you can see nothing cancels. You can see it doesn't simplify any further. Okay? Any questions there? You sure? Okay, so let's take a look at the next couple. We've got 3 or 4 more problems to do. We're going to look at this one right here. This was multiplication up here. Now we're going to take a look at division. How do you handle division with fractions? Okay, you take the second one or the bottom one and you flip it over and you multiply. So I'm going to rewrite this as 12a to the third 5b squared times, flip this over, 15 and b on the top, 4a squared on the bottom. And then I start simplifying from there. So I'm going to cancel the 5 with the 15, that's a 3. That b with one of those b's. The 4 with the 12, that's going to be a 3. And the a squared with 2 of those guys there. Okay. Now I usually like to cross off with a slash so I can still see the original problem. Okay, sometimes that doesn't show up very well. But let's take a look at what we've got for an answer here. On the top, I have a 3. Whoops, I've got 2 3s, don't I? So I have a 9. What else? An A. What about on the bottom? Only a B. And look, because we cross-canceled the right way, simplified answer right there. Any questions? Okay, please watch on this one. Okay, if you're going to save yourself a little bit of time, here's what I'd like you to do. Factor this one, so that's going to be y minus 6 and y plus 6. Factor this one. I need numbers that multiply to be positive 16 that combine to be negative 8. Negative 4 and negative 4. If you wanted to write that down as a perfect trinomial square, that's okay. Change this to times. Flip it over and factor at the same time. So factor the bottom, and where are we going to put its factors? On the top. So I've got a y here and a y here. Multiply to be negative 12, combined to be negative 1. Negative 4 and positive 3. Factor out the 3. You're left with y minus 6. Okay, here's the factored form. I flipped it over, so I'm multiplying, and now all I have to do is cross things off. Cross off common factors. Y minus 6 with y minus 6. Y minus 4 with y minus 4. Anything else? Nope. So I get y plus 6, y plus 3, 3, y minus 4. Probably good to move the 3 out front. And again, we leave it factored so anybody looking at that could see, gosh, it's already simplified as much as you can possibly get it. Okay? Are there any questions? Okay. Then 2 more problems. We good? Everybody got that one? Okay. So this 73 probably isn't too bad, and 81 a little bit on the interesting side. Write the simplified form for each of the following. Be sure to list all restrictions in the domain. So here's what we ought to do. Sticking with what we went over before, factor everything. So that's going to be t minus 10, t plus 10, 5. Let's see, that's going to be a t plus 4, right? Times t plus 4, t minus 10. Now, what do I do before I simplify? Find the domain. So, do I have to look at the top? No. Division problems come from the denominator. So who cares what's on the top? Let's look at the bottom. Is 5 going to mess us up? No. What about t plus 4? Yeah, t cannot equal negative 4. And what from here? 10. Okay, now let's simplify. Cancel off the t plus 4 with the t plus 4. Cancel off the t minus 10 with the t minus 10. Well, this is really good because this means f of t is, the only thing left on the top is a t plus 10, and the only thing left on the bottom is a 5. Now, let me just call your attention to this because this will come up again in this class and especially in 1050. Look at this right here. This is the final result. If you just looked at the final result, does it look like anything's a domain issue? So why did we write down you can't plug in negative 4 and 10? Part of the original problem. Remember, it's the original problem that derives those domain issues. It's not the simplified version. Okay? If you graphed this, it would be a line, but it would have a couple holes in it. It would have a few places where there are no points, and they would occur at t equals negative 4 and t equals 10. Yeah.
So with this problem, we can't cancel off 10 and 5.
Zach asked a great question. I didn't even see that. Can you cancel off the 10 and the 5? Yes or no? I see some shaking heads. Luckily, none of those are going this way. That's good because the answer is no, you cannot. Can somebody state a reason why you can't? Why can't you cancel the 10 and the 5? What was I doing?
They're married.
Oh my gosh. Yeah, the T and the 10 are married. If I knew how to draw musical notes, I'd put musical notes and hearts. Oh, it's in red. Oh, nice. Okay. All right, that's why. I would say you can cancel factors, not terms. Okay. Ten's a term, 5's a factor. Okay. All right, let's take a look at the last one then. Okay. We got this rational expression here divided by this one and then times this one right here. What's the order of operations?
Doesn't matter.
Okay. It's PEMDAS, right? Please excuse my dear Aunt Sally. But it's not in the order they come. When you get to multiplication and division and addition and subtraction, if you don't know this, okay, make sure you have this straight because you're going to screw some things up sooner or later. Multiplication is not more important than division. It comes in the order, you do it in the order they come. Same with addition and subtraction. Okay? So it's not always multiplication first, then division. It depends on what order they come in. One is not more important than the other. So we take this one, divide by this one, and then times by this one right here. We do it in the order they come. So do I have to flip this one over, or do I have to flip both of them over? Just the middle one. That's the only one I need to flip over. So if I'm going to do this problem and save myself some work, I'm going to factor this and write it here. Good to recognize those. Perfect square of 2x, perfect square of 3y. So this is 2x minus 3y, 2x plus 3y. Recognize that? Perfect cubes. Perfect cube of 2x, perfect cube of 3y. So you got to know the formula. It's going to be 2x minus 3y, and then this stuff is going to be 4x squared. It's going to end with a 9y squared, and the middle term is going to be 2 and 3. That's a 6xy. times, let's flip this one over. So take out a 3, I'm left with an x minus y. Put this one on the bottom and take out a 2, I'm left with a 2x plus 3y. We doing okay so far?
No, you missed.
What did I miss? Oh, there's a 3 here, isn't there?
Yeah.
Is that it? Good. And then let's write down this one when we factor.
Isn't that not at 3, it's a 2?
Where?
The one that you...
We're good? Okay. Look at this top right here. Look at that numerator.
Let's see.
It doesn't factor. It does not factor. It looks like a perfect square of 2x, perfect square of 3y. Multiply them together, but then you have to double it to get the middle term. So this is prime, so let's just leave that alone. And that's actually good news, because take a look at the bottom of the first one. But if you didn't know how to factor difference of cubes, you wouldn't have that one sitting down there. Does this one factor? I would call this a difficult trinomial. It's not a perfect square, because that's not a perfect square. Multiply these together. Positive 12. Are there numbers that multiply to be positive 12 that combine to be negative 8? Multiply to be positive 12, combine to be negative 8. Negative 6 and negative 2. So you could do this one by grouping. Let me slide this over. We could do 4x squared minus, I'm going to change, I'll leave the same color. 4x squared minus 6xy minus 2xy plus 3y squared, and then factor from there. Let me write down what you're going to get. That's what you get if you go through and do it. Good? Okay. And from there on, now all right, maybe fun's a stretch, but it's almost fun. You just start crossing off common factors. That ugly mess with that ugly mess. Those two with those two. Let's see, I can cancel this one off with this one. And let's see, anything else? Nope. So that means the only thing left on the top is a 3 and x minus 3y. And on the bottom, I've got a 2x minus y, and a 2x minus 3y. Now, I would really like to cancel the 3y with the 3y. Why not? They're married to different things, right? You can only cancel off married partners, blah, blah, blah. Okay. All right, good luck with that one. Okay, that's it. Good luck with the homework. If you've got questions and want to stick around and ask, that's great. If not, if I don't have the test back, they turn into zeros. So make sure I've got your test sitting up here. Other than that, have a great day.